Hello everyone, welcome back to the second session of insertion sort. Today, as promised, we'll be discussing how to code insertion sort algorithm in Python. Shown here is an array where insertion sort is getting performed, and this is the random ith iteration. So you can see already the array is sorted. The green colored elements are sorted and the uncolored are unsorted. Now it's time that this one has to be inserted to its proper location inside this sorted array. So to start with, I would mark this element and name it as AI, since this is ith iteration. Now when I compare this AI with 8, you can see in insertion sort, if 8 is greater, it is to be shifted to this location, and on shifting you might lose the value of 1. So what has to be done? Of course, the first thing what we have to do is the ith element, or the element which has to be inserted, has to be safely taken out and kept it in a temporary variable. So I am naming that temporary variable as temp. So take the AI and store it in a temporary variable temp. Cool. Now we can begin with our coding. What does the code say? Yes, the AI has to be kept in temp. Forget about the I right now, we'll be discussing it in the next slide. Okay. Now start comparing this temporary element with the sorted element on the left. Okay. Now the sorted element on the left, I have denoted it by AJ. Okay, so this is AJ. Now what is J? J is actually 2 here, and if I consider with respect to I, J is I minus 1. So J begins from I minus 1. So this temporary element will be compared with the element on the left denoted by AJ, where J is equal to I minus 1. So let me begin the comparison from I minus 1th position. Now who will be getting compared? Yes, this element is AJ. So if AJ, the sorted element, is greater than this temporary variable, so if I say 8 is greater than 1, yes, what has to be done? 8 needs to be shifted. So 8 will be shifted to this location. How do I code that? AJ should be kept at AJ plus 1. So this was J. So this is going to be J plus 1. So AJ will be moved to AJ plus 1. Cool. What is next? Of course, now it's time to compare this temp with 6. So that means I'm bringing this J from this location to this location. So J is reduced from index number 2 to 1. So to do that, we have to code J is equal to J minus 1. So J is reduced by 1 unit here. Now let me go again and compare this AJ with the temporary element. So from this position, I have to move over here. So will this if statement do that? Of course not. Since it's a repetition of things, it is iteration of things, we need an iterative statement. So while is the best choice right now, let me go back and see AJ and temp. So this is AJ now compared with temp. Is it greater? Yes, of course. 6 is greater than 1. So what we do is shift it. How do we shift? AJ is kept at AJ plus 1. Again, J is reduced by 1 unit. That means J is equal to J minus 1. It's the next element AJ. Go back and compare AJ with temp. So AJ is compared with temp, 2 greater than 1. Yes, again true. So what has to be done? The shifting. Okay, so let me proceed with the shifting and then reduce the value of J. So J is reduced by 1 unit, and if I compare AJ, what's happening? A of minus 1. A of minus 1 implies I'm going to take this element and get it compared with temp. Am I supposed to compare the last element with temp? Of course not. That implies the negative indexing of j should not be allowed. Okay, so adding on with the while statement, I will be actually putting one more condition, that j, the index number of j, okay, should be always greater than or equal to 0. As you can see, all these sorted elements will be coming from index number 0 to I minus 1 position. So this condition should always be considered when you are doing the insertion sort. So it's very much clear over here. The shifting should happen only in the cases when the sorted element aj is greater and also the j should have a positive index number. Good. So since the condition j greater than 0 is not satisfied, I will be definitely thrown out of this flow. So what should I do now? This one needs to be inserted over here, right? For doing the insertion, I have to put a reverse here. That means j should be, yes, increased and brought over here. So it is not at aj that the element is going to be inserted. It should be aj plus 1. Okay, so take the 10, bring back to aj plus 1 and then put it. So that's how the ith iteration is considered in an insertion sort. But if you review the previous example, we did insertion sort with a given set of elements like this and started our iteration from the second element, that is index number 1. Okay, then again we had considered index number 2. The shifting and the shuffling happened with the sorted array. So entire set of code has to be repeated with index number 2 as well. Similarly, when I shift to next element, that is index number 3, the comparison, the shifting and the insertion all needs to be considered with this index number as well. Similarly with index number 4. So how many times the entire set of code has to be repeated? Yes, it should begin from 1 till I reach the last index number. And what is the last index number? If I'm going to write with a range function, of course n minus 1 is the last index number. So range function, I have to supply n for that. So for I in range 1 to n, you have to repeat the entire code for each and every ai element. Cool. So I think the algorithm is clear now. It's time to do some lab exercise. Okay, so moving ahead, I'm going to make a function for insertion sort and supplying an array A. Okay, first of all find the length of the element. N is equal to, yes, len of A, and then start the for loop for I in range. Yes, what was the iteration? 1 to n. Now take the ai into a temporary location. So temp is equal to a of I. Start with the adjacent index number. So j is equal to I minus 1. Cool. Now let me compare all the sorted element. While aj is the sorted element. If any of the sorted element is greater than the temp, and also you have to check index number should be positive. So j should always be greater than 0. Okay. Then you have to shift this aj to aj plus 1. So aj plus 1 is equal to aj and reduce the j. So j is equal to j minus 1. Cool. So as soon as the element is less or the index number exceeds, index number becomes negative, it's time for insertion, and insertion is performed in the aj plus 1th location. So aj plus 1 equal to temp. Fine. And after completion of first iteration, let me print it. Print array. After the iteration, format I comma a. Cool. So my function is complete. It's time to call the function insertion sort. And let me supply a few elements. Cool. So the elements were 12, 4, 2, 6, 7. So you can see first iteration 4 is inserted at the proper location. Second iteration 2 gets inserted to its proper location. Then it's time for 6. 6 is inserted and finally 7 gets inserted to its proper location. So that brings us to the end of this session. Hope you enjoyed insertion sort. Thank you so much for watching. Happy coding!